Hello, this is our second online lesson. In the first one yesterday, we covered the mean, and today we are going to cover the median. Tomorrow we will do the mode and the range. The word median is one that you might actually hear in the news a lot. I always try to give credit to where I get my information. This one's from Zillow. After the Great Recession, housing prices were still going down, and then over the past 8 years, they've steadily climbed and kind of leveled off, and with COVID-19, probably going to drop again. But this is not looking at the average home price, this is looking at the median home price. So it's a different concept. It's related to the mean, but it's different, and the two of them have different uses. We'll go to the dictionary and find an actual definition for this. The median is the middle number in a series of numbers. It's in the middle where half of the numbers are larger than it and half of the numbers are smaller than it. So you don't necessarily have to calculate things unless there's an even number, as this points out, in which case you take the average of the two middle numbers. Don't worry about that right now. Just think about it, look at that second definition, as a midpoint between a set of numbers. And we're actually going to talk about histograms briefly tomorrow, but it shows us the middle point. So I'm going to give you a set of numbers. These are put in order for you. And which of these is in the middle? Which is the midpoint? Which is the median? Most of the time when you get numbers, whether it's a large set of numbers or a small set of numbers, they are not necessarily in numerical order. So in the second case, you have to put them in order and then figure out what the midpoint number is, or what the median is. You could even have a list of numbers that's very small, two numbers. And if you're thinking that those two numbers look a little bit familiar, you are right. I gave those to you yesterday when I was describing how we calculate the average. And in this case, actually the average and the median are the same. To figure out the average, we add together the numbers in the series and then divide by the number of numbers in the series. So 10 plus 2 is 12. There's two numbers in the series, so 12 divided by 2 is 6. And I gave you a number line yesterday, and I've moved it up so that it will not interfere with the picture-in-picture. And I pointed out that if we take 2 and 10, and we look for where the average is, 6, we notice that it is an equal distance from the 2. 1, 2, 3, 4 steps, and 1, 2, 3, 4 steps. It's the midpoint. In this case, 6 is the median. Half of the numbers are larger than 6, and half of the numbers are smaller than 6. And 6 is the midpoint. So in this case, the median and the mean are the same. And if you have an even set of numbers, you need to find the average of the two numbers in the very middle. So let's take some series and look at them. I have 4 numbers in this series. So what's the midpoint between 4 and 6? In this series, I'm going to have 3 numbers that are smaller than the midpoint and 3 numbers that are larger than the midpoint. So I've got to calculate the average of the two middle numbers. Finding the median is generally very easy if you have an odd set of numbers. It's interesting, however, to see how the median and the mean are sometimes related. In this case, I have 5 numbers, so the median is clearly 7. In this next series, I have 5 different numbers, and the midpoint, the median, is still 7. I have 2 numbers larger than 7 and 2 numbers that are smaller than 7. Same thing here, 2 that are larger than 7 and 2 that are smaller than 7. So 7 doesn't tell me anything about the numbers around it. If I want to find out more about the numbers around 7, then I need to use the mean. I need to use the average. So again, to calculate the average, I add together the numbers in the series and then divide by the number of values. So add together these numbers and divide by 5. And then we can do the same thing for the second set of numbers. We can add these numbers together and then we can divide by 5. In that case, we find something interesting. The median is the same, but in this case, the average is now 20. That's a big difference, the average being 6 here and the average being 20 here. So you can have the same mean, but completely different averages. How do we use these practically? Well, let's talk about school a little bit. I'm guessing that you have a run for the arts, and unfortunately our school systems don't fund arts as well as they should, and so we do special fundraisers for them that we don't have to for other subjects. But in the run for the arts, you often ask people to sponsor you. And people might decide to give a fixed amount, and they might say, I'll pledge this many dollars for every lap you run. So let's say you go to your grandparent and you say, hey, will you sponsor me for Run for the Arts? How many dollars will you give me for every lap I run? And they say, well, how many laps are you going to do? How big is it? What do you think? How long do you have? And you don't know all those things, but you remember your teacher saying, last year, the average was 18 laps per student. So on average, students did 18 laps. So you tell this to your grandparent, and your grandparent says, $18 a lap. Well, if I gave you $1 per lap, that's $18. That's not very much. If I gave you $2 a lap, that's $36. An average, let's say you do more than 18 laps. You do 20 or 25. That's $40 or $50. So maybe your grandparent says, great, I'm going to pledge $2 per lap. Go out, get some exercise, and raise some money for arts at your school. And then you go and you run your laps, and it turns out that you ran 12 laps. And your grandparent says, wow, you didn't really do that many laps. Well, sometimes the average can be skewed, and that's a real math word, by some big numbers. So let's look at what the actual statistics were for the class last year. This is the number of laps run by each student. So what's the midpoint of these laps? Well, the midpoint is 12. Half ran less than 12 laps, and half ran more than 12 laps. So it's a real number. The median is 12. But this average is skewed by the fact that we have two people who ran 60 laps each. Well, it turns out that in the class last year, there were the Wonder Twins, Zan and Jaina, and their mom was an Olympic athlete and has been training them to be Olympic athletes too ever since they could walk, and they each ran 60 laps. So the fact that they ran 60 laps changed the class average. It made it seem like everybody ran about 18 laps, and that's not really true. Instead, 12, the median, was more realistic because a lot of people ran 10 or 11 laps or ran 12 or 13 laps, and these two were rare. So sometimes the mean and the median, sometimes the average and the midpoint can be really different from each other. And so sometimes when we look at data, we need to look at more than just some of those numbers. How does this play out in the wider world? Well, all of you are going to be voters someday, so we can look at what has happened in the last 30 years to average incomes, and we can look at what's happened to income for median incomes. And what's happened is that average incomes have gotten higher and higher at a faster rate than the median. We've got some Wonder Twins who are making lots and lots and lots of money, and so that makes it look as though, wow, everybody's doing great because the average salary per year is going up. But what's happened instead is most people, average people, the median, their salary is not going up as fast. And this might get confusing, but these dots show how the ratio between the average and the median income has changed, that over the past 30 years, things have kind of gotten worse and worse for everyday people. So again, you'll be voters someday and we can fix that. I'll give you one more thing to ponder. Last class, I ended by talking about two student teachers that are working with Ms. McKenzie. Ms. J's class and Mr. K's class had similar average scores on a test that they took. Both teachers were teaching the same material. Both sets of students took the same test and are similar groups of students, and their average score was pretty similar. But when I look at the median, I find that half of Ms. J's class scored more than 82%, and only and half of Mr. K's class scored above 78%. So that tells me that Ms. J's class did a lot better on the test than the average might actually indicate. And I have intentionally not shown you the actual data from these two teachers because I want to save that for tomorrow when we talk about the mode and the range.